And we have another spring K1, and then another damper C1, and then attached to another mass MA. But MA here is having a wheel there, and there is a force applying to that direction is FT. All right. Okay. Okay. Basically, the derivation is the same as the one that we always did in any example in class, right? But the only trick here is I think the trick here is the direction of the force. Okay, you can see that if you notice the direction for x1, and there is another x1 here. Okay, and also the direction for the force is given to the left. So so when you derive the equation, okay, when you derive the equation, you might consider that the direction is the positive one. Okay, so we consider the direction to the left is the positive one, right? Other than that, the step is similar. Okay, this step is similar. All right, so let's consider for MB here. Okay, if we draw FBD, okay, the first step is always FBD for MB, right? So we have force for spring number 2, and then we have force for spring number 1, and then we have a force coming from damper. But then there is also additional force due to C2 here. Okay. All right. So again, you need to consider the direction of force. Okay. So let's say for spring number 2, K2 then. Okay. We know the direction, the displacement will push the spring there. So meaning that the spring will be in compression. Okay, so the reaction will be to that direction, right? So that will be the direction for spring number 2, right? And then for C2, okay, this is for C2. Okay, C2 here. Okay, C2 is actually a friction force. Okay, but here we're going to consider that the friction force is actually a damp energy that trying to stop the movement of the kite. Okay, so we're going to consider C2 as another damping element. Okay, so again, force from C2 or damper number 2 will be opposing the direction of the displacement. Okay, and then for spring number 1, we're still going to consider X1 is bigger than X2. X1 is bigger than X2 because X1 is the input. Okay, the output is X2, so we consider X1 is bigger than X2. So therefore, spring number 2, spring 2 will be in compression, right? Okay, so spring number 2 will be in compression. Therefore, the reaction will be to that way. Okay. Right, so here, this will be the direction for spring number 2. And as for the damper, okay, the damper is said to be opposing the direction of the displacement. So the displacement is to this direction. So we consider the damper to be in that direction. Okay, we try to pull the movement of the displacement, okay, of the mass. Right, so from there we're going to have the equation by considering this is the positive, So we have Fs1 minus Fs2 minus Fd, and also minus Fc2. You can put any name. You can say there is a spring damper force, but this is just a notation. Will equal to MBD square X2.
Doktor,
Yes?
boleh tolong explain sekali lagi tak kenapa damper tu dia lawan arah displacement?
Damper, we consider damper damper is a damping element. Okay, damping element is used to damp the energy of the system. So, so in order to oppose the direction of the mass, so the direction of mass is considered to the left. So we consider the spring of damper. We try to oppose the direction of the displacement. Okay, if the direction is the same as the displacement, all right. So the energy, meaning it's like the energy is the same, right? When we consider the direction is to the other direction, so meaning you will have some minus there, right? Okay, so the displacement is to that direction. The total force that caused the mass to displace to the left, the direction left, right? Must be minus the force due to the damper, because the damper is trying to oppose the direction. So that's why we consider the direction for the damper is to the right. Okay. Okay. And then for MA, I think MA sama lah kan. MA, we're going to have FT, right? And then we have another two then. So the spring is in compression. So this one is the direction to that one. And then this one will be the direction to here. All right. So again, assuming the direction is positive to the left, so we have Ft minus Fs1, right? SS1, and then plus ini this one to this direction. Okay, minus Fd. Okay, equal to MAD square x1. Okay, MA x square this one. All right, and then we write all the equation for Fs1 equal to K1 x1 minus x2. Then for F damper is CD x1 minus x2. For K2, Fs2 is equal to K2 x2. And then for damper 2, for Fc2 kan, kita bagi nama, equal to C2D x2. Okay. Alright, so based on that, you will be able to draw the block diagram. Okay, do we need to draw the block diagram?
Boleh juga, Doktor.
Alright, so basically it doesn't matter the direction, because the negative will be only on the summation point. Okay, X2 is the output. Okay. Right. Start with x2. Okay, x2, we're going to use this equation. We're going to use that equation. So we have x2. X2 is equal to 1 over MA. 1 over MB. 1 over MB. Okay, 1 over MB atas tu. FS1 minus FS2 minus FD minus FC2. Right? So we know we need to multiply with 1 over MB, and then we have a summation point. So let's draw two summation points because we have 1, 2, 3, 4. Okay, so let's consider tadi FS2 apa? FS2 is KX2. FC2, okay. So let's consider here 2. This one is FS1 minus here is FD, and then here is FS2, and here is SC2. Okay. So FS2 is positive, so the sign is positive. FS1 is positive, then FS2 is negative. Okay, so this one is negative. FD is also negative, and FC2 is also negative. Okay, so we're going to solve for FS2. It is K2X2. K2 multiply with X2. And then for C2, it is C2D. Okay. All right. So we already used this one. Okay, we already used this one, and this equation. Okay, the equation. All right. Now we need to solve for FS1. Okay. Let's use this equation here. Okay, FS1 is K1 X1 minus X2. K1, and then here is X1 minus X2. Okay, so X1 will be solved using this equation here. All right. So if you rewrite the equation, okay, let's rewrite the equation here. So X1 is equal to 1 over MA multiply with FT minus FS1 minus FD. Okay. Ni nak sambung ni. Masuk pula ke ni. Sekejap. Right. So right, so X1 here is 1 over MA. Then the summation is FT is the input. FT is the input, and then minus Fs1 minus Fd. So we already have Fs1 and also Fd. Right, so the sign is minus, 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 plus. Right. And then x2 is already here. Okay. And then we need to solve for Fd. Okay, Fd is CD x1 minus x2. Okay, so CD x1 minus x2. Because here he x1 minus x2. Okay, multiply with CD we get Fd. Okay, so then we get we'll be able to connect that one. Ini Fs berapa yang ni? Fs1. Okay, this is Fs1. Okay, so Fs1 is already here. We just tap, go to here, and similar to Fd, we already have Fd there. So we're going to connect to Fd. Okay, so that's the block diagram of the system. Okay. All right. Any question regarding this one? Okay, so I think the trick here is in terms of the direction there. Okay, you maybe want to consider this direction to be positive. So then, basically, it's not wrong, but you might get confused because the input letter will minus Ft because the direction of Ft is to the left, while your consideration, your assumption to the right is the positive. Okay, so that is not wrong. You can still assume the direction to the right is positive. The difference is only here. Okay, so instead of positive here, it will become negative. So not to worry about the sign, the sign negative, positive. Even though your equation is negative Ft plus Fs2 plus Fd, and then you see the input is in negative. That is okay because the difference is only at the sign here. Okay, so if you have a negative Ft, then the sign will become negative. Okay, but for easier, in order to make sure that you're not confused, just consider to the left is the positive. Right. All right, let's go to the question number 2.
Madam,
Okay.
is it the direction of damper always opposite to the displacement?
Is it the direction of the damper always? Yes, we consider the damper always try to oppose the movement of the direction.
Okay. Thank you, madam.
Okay.
Doktor, kalau dekat mass B tu tak ada roda, kita kena kira dia punya F sama dengan MA juga ke?
Kalau dekat mana? M apa?
Dekat mass tak ada roller.
Yes. Macam MB tu tak ada roller. Okay.
Kita anggap dia ada F sama dengan MA juga.
Yes, we still consider that there is F equal to MA because there is displacement, because you can see there is X2 there, meaning the mass is having displacement. Ada pergerakan X2.
Oh, okay, faham doktor.
Doktor, yang MA tu,
Okay.
FD still ke kanan force dari FD tu.
FT.
FD yang MA yang bawah kiri tu.
Damper.
Damper punya
damper, FD. Okay. Sekejap Okay. Untuk MA this one. Okay. Because we consider the damper is the force of the damper will oppose the movement of the mass. Okay, So that's why we consider the direction of FD on the MA. Okay, the direction of FD on MA also to the right, meaning try to oppose the displacement of MA. The displacement of MA is to the left, right? If you refer to the diagram, okay, we consider that the positive is to the left, x1. Okay, so that's why we consider the damper. We try to oppose that movement. Okay, the damper we try to oppose that movement. Okay, boleh tak jawapan tu? Alright, let's continue with block diagram manipulation. Okay, block diagram manipulation. Right, we have two submission.
Doctor,
Yes.
I got sent one question at the WhatsApp. If I get the equation, if minus at the sign there, how can I draw the block diagram?
Sekejap G3. Before G1 there is G5. Ini macam soalan yang saya dah bagi dalam tu kan? Ini bukan dalam, ni dah ada ke? After G2 there is G6. It's plus, it's minus. Okay, then there is another one. G4 plus. WhatsApp section berapa? Siapa tadi yang tanya? WhatsApp you section berapa? Siapa tadi yang tanya soalan?
15, 16.
15, 16.
15, 16. Apa soalan you?
If I get the equation like this and the output is Y2, how can I draw the block diagram? Because got a minus there. For example, because I have encountered this problem.
Oh, okay. The output is Y2. Boleh tak you bagi full? Tak boleh bagi separuh macam ni.
Because I using the different direction, so I get the...
Okay.
So this means the direction is wrong, is it? We must use
the direction, only one force acting on the body?
At the block 2, yeah, it's one force.
There is only one force.
Yeah, so if I use the... If I reverse the direction, it will become like this.
The direction of Y2 is opposite to direction FS2.
Y2, yeah. If so it not possible to get this equation, is it?
I think I haven't yet seen this kind of equation.
Okay, thank you, doctor.
Okay.
So it means I was wrong. Okay.
Okay, question number 2. Okay, this question asks for block diagram manipulation, right? Okay, block diagram manipulation. All right. Okay, so block diagram manipulation. All right. So, if we want to solve for, this feedback, okay, we cannot do it due to this peak off point, right? Okay. If we want to solve, okay, so that is the thing that we can start, which is to solve the feedback there. So we need to move this peak off point. Okay, so the peak off point need to be moved, right? So you can move to here, right? But then if you move to there, you cannot solve the second feedback. Okay, so you should move to here. Okay, so if you move to there, I'm not going to draw it. Okay, I just going to edit it on here. So we're going to move it there. So meaning this G4 here, right? So peak off point. Okay, moving peak off point toward positive. So you have to multiply with G or 1 over G?
1 over G.
Okay, 1 over G. Right, so therefore the new block will become, okay, you should redraw again, but I don't want to redraw it. Okay, so you're going to, okay, we're going to add a new block. Okay, so that will become G4 over G1, G2. Okay, because you need to multiply with 1 over G1 and then multiply with 1 over G2. All right, so by doing that, now we can solve for this part here, for the feedback, for the first feedback. Okay, we can solve for the first feedback, so it will become G1 over 1 plus because the sign is minus, G1, G5. Okay, so now let's draw the new one. Okay, summation point. This summation point is still exists because another loop for G6 there is still there. So this one here is G1 over 1 plus G1, G5. Right, and then we have G2. And then we can combine these two. We can combine these two. So that one will become G3 plus G4 over G1, G2. Okay, so when we have this feedback here, plus minus, then we still have another one. It is after G2 here, G2, and we have G6. Okay, so it is plus plus, right? Okay, so far. So G3 plus G4 over G1, G2 is when we solve for the feed forward. Okay, feed forward. Okay, so we add the two together. The G3 plus G4 over G1, G2, right? And then we need to solve for feedback here. Okay, but notice the sign here is positive, right? It's still a feedback. Okay, it's still a feedback, but then the sign is positive, meaning in the equation we're going to use minus. Okay, so that one will become G1, G2 over 1 plus G1, G5 over 1 plus G1, G2 over 1 plus G1, G5 multiply with G6. Alright, this one can be cancelled. Multiply here, it will be equal G1, G2 over 1 plus G1, G5 plus, okay, minus. This one here is minus, okay, because the sign here is positive, so the sign there is minus. So this one will become minus G1, G2, G6. Okay, that is for the feedback. Okay, due to the sign, positive sign here, in the equation it will become kg over 1 minus kgh. Okay, if the sign is negative, it become 1 plus kgh. Okay, so due to the plus sign, this one here become minus. All right, so now we can combine the two together. Okay, so we before we solve for the final loop, we need to multiply G1, G2 with the G3, G4. Okay, so let's multiply G1, G2 over 1 plus G1, G5 minus G1, G2, G6. Multiply with that one will become G1, G2, G3 plus G4 over G1, G2. Okay, so it is multiplied, so we can cancel these two, right? So it will become G1, G2, G3 plus G4 divide by 1 plus G1, G5 minus G1, G2, G6. Okay, so then we're going to solve for last loop. Okay, last loop here, this one, the loop there. Okay, so H is only 1. Okay, so Y over U will equal to G1, G2, G3 plus G4 divide by 1 plus G1, G2 minus G1, G2, G6 divide by 1 plus, because the sign is negative, so 1 plus this one multiply with 1. Okay. G1, G2, G3 plus G4 divide by 1 plus G1, G2 minus G1, G2,
Doctor,
G6 multiply with 1. Yes.
is it supposed to be 1 plus G1, G5 minus G1, G2, G5?
G1, G5. Yes. Okay. Correct. G1, G5. Okay. So you will multiply 2 here, then so you can cancel these 2. So you will get G1, G2, G3 plus G4 divide by this upper term 1 plus G1, G5 minus G1, G2, G6 plus G1, G2, G3 plus G4. Is it? Right? Which one? Okay. So that will be the determinant. G4. Okay. G1, G5, G1, G2, G6, G1, G5, G1, G2, G6, G1, G5, okay, G1, G2, G6, okay. Then we have another G1, G2, G3, okay. Dapat ada G4, satu lagi. Ada siapa boleh notice kat mana saya silap? Sebab saya perasan ada G4 kat belakang ni. Macam G1, G5, one loop. Okay. Boleh? Boleh langkah 2 blok boleh. 3 blok pun boleh. Summation point pun boleh langkah 2. Dia tak boleh langkah summation point. Dia tak Pick off point tu tak boleh langkah summation point aja. Summation point kalau you move pun you boleh langkah 2 juga. 2, 3 boleh. Tak ada masalah. You nak langkah 2, 3, 4 tak ada masalah. As long as you tak langkah another pick off point. Selagi dia masih lagi ada block you boleh langkah lah. Tak ada masalah. Sekejap. G1, G2, G1, G5. Okay, 1. 2 is G1, G2, G6. Okay, ada satu lagi G4 tu. Okay, betul. Ada G4. Okay, so this is the answer. Okay. Okay, so for block diagram manipulation, the trick is normally like that. Meaning you have to move something before you can solve for a feedback. Normally the objective is to solve for feedback or feed forward. Okay, so in order to solve feedback or feed forward, we need to move a pick off point or a summation point. Okay, so make sure you move like I always said that a pick off point or a summation point only can be moved over a block. Okay, you cannot move over another pick off point. Okay, meaning summation point cannot be moved over a pick off point. Okay. Alright, so is as long as you remember all the rules, moving a pick off point toward the input, you need to multiply with what, move it toward the output, summation point toward the input and toward the output. Okay, if you remember the CFA yang saya bagi tu, it should be okay lah. Alright. And then another one for the feed forward here. Okay, feed forward. So you need to follow the sign. Okay, feed forward here. Okay, you need to follow the sign. So this sign is positive. So that's why G3 positive plus G4 over G1, G2. Okay, but if let example, the sign here is negative. Okay, so it's not become plus anymore. It become G3 minus because it's actually minus G4 over G1, G2. Okay, so it depends on the sign on the summation point. Okay. All right. Okay, question 2. Question 2, Laplace. Okay, find the inverse Laplace transform. So that one is just to the partial fraction decomposition there. Okay, you need to remember or refer to the table, partial fraction table there. Yeah, I think this is for the function number 1. So you're going to have A over S plus 1 plus B over S plus 2. All right. For B, okay, a differential equation describing a dynamic system is d2 square, this d square y over dt square plus 7 dy dt plus 12 yt equal to 2 ut. Okay, so the tips here is ini tak ada apa lah, sama je ni. Okay, so here it mentioned that if a unit step input, okay, unit step input, okay, it's mentioned ut is equal to 1. So this is meaning unit step input. So meaning in Laplace, it will become us equal to 1 over s. Okay, so if ut equal to 5, okay, so this is not a unit step input, it's 5 unit step input. So it is in us, it will become 5 over s.
Doctor, how is the U zero?
Pardon?
U bracket 0.
U bracket 0.
It will become 0.
U bracket 0.
Yeah.
Okay. This is initial condition. For input, because U is input, okay, equal to 0.
Oh, okay. Thank you, doctor.
Right. So meaning meaning here your US is not just 1 over S. Okay, meaning maybe your input is not step input. Okay, your input maybe have something like US is equal to apa at least du plus u. Okay, maybe in term of output side, there is du plus u. Okay, meaning when you inverse to Laplace, so this one we have u sus bukan sus minus u0. Okay, so here u0 is equal to 0. Alright.
Note.
Yes.
Yang for initial condition tu memang kita set it equal to 0 for the input.
Macam contoh in this question, okay, the initial condition is mentioned. Okay, initial condition y0 is equal to 0 and y prime 0 equal to 1. Ataupun ditulis dy 0 over dt equal to 1. Sometimes you write y prime 0. So meaning 0 there, 0 in the bracket meaning time equal to 0, t equal to 0. Okay, so this is t, right? T equal to 0. So meaning it is initial. Okay, initial condition equal to equal to 0. Okay, or maybe give you y0 equal to 2. Okay, so meaning the initial condition has a value equal to 2. It's not starting from 0 but instead it's starting from 0.2. Okay, kedudukan itulah.
Doktor, yang SUS tu terus jadi 1 kan?
Yang mana?
SUS.
USU tu akan apply lah. Kalau USU step input 1 over S lah. So multiply with 1 over S. Itulah. All right. Last one is the first order system. CND is first order system. All right. YS over RS is equal to 3 over 5S plus 4. Okay, and then step input equal to 3 volt. Okay, what is the time taken to output to reach 98% of its steady state response? Okay. All right, so first let's convert into standard form. Standard first order equation. First order transfer function. Right, so first order standard transfer function meaning we need to divide by 4, right? Because the standard is K over 1 plus TS. Okay, so 1 is the we need to make sure the equation has 1 there. So that's why we divide 4/4. Okay. So by divide 4/4, this one will become 0.75. Divide by 1 plus 5 bagi 4 berapa? Saya letak je lah 5/4 5/4S. Okay. So we know that time constant is equal to 5 bagi 4.
1.25.
Okay. 1.25. And then K is equal to 0.75. Alright. Okay, so then we can calculate for Y final or Y steady state, which is equal to K multiplied with U. Okay, U is 3. Okay, and K is 0.5. So here is 0.75 multiplied with 3. Apa? 0.75 darab 3, 2.25. Okay. Alright. So the question here is what is the time taken for the output to reach 98% of its steady state response? Okay. So what is the value for 98%? Okay, 0.98 multiplied with 2.25 will equal to 2.25 is 2.205. Okay, so this is Y, YT tak tahu. YT equal to 2.205. Okay, so we want to find what is T there. Okay, so we're going to put into the equation. Okay, the standard equation for YT is equal to K multiply with 1 exponent negative T over time constant. Okay, if you before this the standard equation is 1 minus exponent negative T per T, but it's actually multiplied with K because we consider K equal to 1. Okay, so basically this is the general transfer function. Right, so we know all the values. Right, YT is 2.205 equal to 0.75 tadi kan. Okay. 0.75 minus 0.7 ataupun tak payah minus kat situ lah. Minus 1 minus exponent negative T per 1.25. The time constant is 1.25. Okay, so we want to find T here. Okay, so all the others ada dalam equation tu, so you should be able to solve for T. Okay. Okay, last one D.
Doktor,
Yes.
untuk yang C tu,
Yes.
nanti kita dapat log negative something, so error
Log negative something. Mana ada log negative something?
Tak silap saya dapat log negative something. Kalau bawa pindah apa semua jadikan.
Bagi dulu 2.205 bahagi 0.75. 2.94 equal to 1 minus exponent negative T per 1.25. Alright. So tukar je lah. So pindah. So exponent negative T over 1.25 is equal to 1 minus 2.94. Right. Okay, so that one will become berapa?
Negative 1.94.
Okay, berapa? 1 tolak 2.94 negatif. Negatif 1.94. So ini eksponen negatif T over 1.25. Kejap. Then we do ln. Ln. Mana negatif? Negatif 1.94. Oh, tak boleh ln negatif tak boleh
Doktor tak boleh.
Sekejap Nanti. Belum. Okay lah.
Doctor.
Yes.
Scroll out again. Yeah. So y equal to ku if I just sub the 0.75 and t to the k calculated directly into the formula and I darab dengan 3. So jadi the equation and then I use the equation.
Boleh kuat sikit tak? I tak boleh catch up you cakap.
Oh, okay. If I dapat t dan k, so and I sub to the formula 1 minus exponent itu formula yt.
1 minus eksponen negatif T per T.
Ya. So darab dengan k. And then k tu darab dengan itu 3 RT. So I just directly sub to the k and t and I darab dengan 3 kat k tu kerana RT kan. So and then I use the equation to find reach 0.9 and sub to the yt, is it? Or cannot?
You sub apa tadi? You okay kat sini okay kan?
Yeah.
Right. 1.25 T is K 0.75. Okay. So now you directly put into YT equal to 1 minus exponent negative T per T.
Yeah, and then darab dengan K ada formula kan? Darab dengan K. And then YT over dengan RT kan? So RT dia dah bagi 3. So I darab dengan K tu. Pergi atas.
You darab dengan K mana pula ni?
Doctor, can I share screen?
Okay.
Okay, I share screen.
YT, yep. Negatif kan? Tadi negatif kan? 0.75. Kalau kalau negatif pun tak boleh.
Doctor, if I like this.
Okay.
I get 1.25 and 0.75.
Yes.
So YT over RT equal to 1 minus darab dengan K kan? Itu formula. So RT dia bagi 3 kan? So kami darab dengan 3. So ini cancel. So I sub value ni jadi
0.75.
And then itu T jadi 1.25.
1.25, right?
And then dia bagi itu YT equal to 0.98.
Oh, okay.
So yang ni kami akan darab dengan itu K plus tiga ni. Jadi itu steady state punya YT.
Okay, faham. Alright.
Okay.
Okay. What your friend did is you can okay. Nampak tak screen?
Tak nampak.
Tak nampak? Share screen. Start broadcast. Okay. Nampak kan? Okay, so kan. Alright, so what your friend did is we just consider okay, yt is equal to 1 minus exponent negative t per t. Okay, so we just first we just need to consider before the okay, we just consider this is 1. Okay, this is 1. And then the question asks what is the time for 0.98. Okay, 0.98. Okay, so we just consider that equal to 1 minus exponent negative t per 1.25. Alright, we don't multiply with k yet because the effect of k is just it just like shifting the value. Okay, so we just need to multiply with 0.75. Tak pula. Okay, if you solve this equation, do you get the t? Siapa tadi yang share screen tadi? Saya tak perasan dia punya nama tadi.
Chen.
Cheng. So if you solve this one, you get t, meaning there is no problem with negative ln.
I think no problem because the minus sign will be cancelled. So it will be calculated. So I calculate now.
0.98, but the final value is not 1 actually.
Yeah, so can I just darab dengan 3 itu equation, so 0.98 juga darab dengan 3. Bukan. Dengan darab tu 3 times k tu.
3 darab dengan k, yes. There is 3 darab k.
So 0.98 juga kena darab 3 dengan k kan?
Yes.
Yeah.
This is the value. That is actually okay. 2.205 is actually 0.98 multiplied with 2.25, where 2.25 is 0.75 multiplied with 3. 2.25. Okay, and then you multiply again with 0.98, right?
Yeah.
It's the same, right? Okay.
Yeah.
Let me think about the k here. K, because we already multiply with k, should we be multiply the k in here again? Okay, let's try here. Let's try this one. Okay, 2.205 is equal to 1 minus exponent negative t over 1.25. Can we solve for t? Ada tak masalah tu?
Tapi itu total you kan, tapi ini equation because dia sudah over 1 kan, so kami juga kena darab itu RT dengan K. I send kat WhatsApp.
Okay, can you please do step by step and then send dekat WhatsApp boleh?
Okay.
Alright. Alright.
Nak tanya pasal initial condition tadi. So
Initial condition, yes.
So y0 equal to 2, so u0 equal to 2 juga
Y y0 equal to 2, then
U0 equal to
u0 equal to 2. No,
ke U0 equal to kosong?
no. Okay, if y0 equal to 2, it does not related to u0. Okay, so the initial condition is not meaning in term of input and output, one another, maksudnya input tu tak ada relation dengan y0 untuk the initial condition lah. Maksudnya kita tak tahu starting dia macam mana. Okay, so basically if there is nothing mentioned about initial condition, we just assume it is zero initial condition. Okay, meaning there is nothing saying that u0 or y0 equal to something, so we consider that is equal to 0. Okay, but if it mention y0 equal to 2, so you just need to replace in the Laplace. Okay, later you will have a form. Later, for example, you have sys minus y0. Okay, this is first order. Okay, if you transform first order Laplace into Laplace form, you get this sys minus y0. So here you're going to replace y0 equal to 2. Okay, and then for the input part, meaning there is nothing mentioned about initial condition for the input part, but you also have u0. So meaning now you don't know what is the value that you need to replace for u0. Okay, so just consider that one to be 0. Because we considered in zero initial condition. Okay. Yes, Yusuf Ikmal. Yusuf Ikmal angkat tangan, kenapa?
Doktor,
Yes.
nak tanya pasal equation yang K equal to Y over U atas tadi, atas.
Y final kan? Y final equal to KU. Yes.
Ni yang ni dia boleh apply dekat first order ke zero order ke macam mana ke?
First order.
Oh, ni first order punya.
Okay. The equation is YT equal to 1 minus exponent negative T per T. Okay. The transfer function Y over U is equal to K over 1 plus TS. Right. So basically if you plot, okay, T is 0.632 ataupun 63.2% from Y final. Okay, so Y final here is equal to K multiply with U. Okay, so depend on the value of K here, you need to multiply with the input. So if your input is unit step input, U is 1. Okay, unit step input. Okay, you expect the system should settle to 1. Okay, unit step input. So U is equal to 1. In Laplace 1 over S. Okay, so you multiply with the K. Okay, so that's why in this equation just now here, okay, Y final or Y steady state is equal to KU. So K is 0.75. The input is 3 volt. Okay, so you get 2.25. Okay, in terms of calculation, you will see this this is like zero order. Okay, because zero order, like you apply input, you get the output. Okay, but for the first order, you can calculate the Y steady state at the steady state region only. Okay, maksudnya bila dia dah capai steady state, dia dah stable satu value yang akhir, value akhir tu adalah K multiply with U. Okay. Sedangkan untuk first order, there should be a delay. So that delay is actually this part here lah. This part, this is macam some delay lah tu, ada delay. Okay. Then this is transient. Transient response. Sebelah sini adalah steady state response. Okay. So only for the part of steady state, okay, we can use this equation. Y final equal to KU. Okay. Kalau you nak kira what is the value for here, you cannot use Y multiply with KU lah. You kena use equation YT equal to supposedly K minus K exponent negative T per T lah. Ataupun K minus 1 exponent negative T per T. Okay. So in transient region, in order to calculate what is YT, you use K equal to 1 minus exponent negative T per T. Tapi on the steady state region, you can straight away calculate like zero order. K multiply with U. Okay.
Okay, Doktor. Thank you, Doktor.
Siapa tadi yang nak share? Ada ke? Okay. K multiply with 0.75. Okay. Alright. Okay, your solution, your friend's solution there for the problem just now, YT equal to K 1 minus exponent negative T per 1.25. Okay. So here is 0.98 multiplied with 2.25, which also equal to 3 multiplied with 0.75. Sabarlah Hana Humaira, minus exponent negative T over 1.25. Okay. Based on the equation, you should get T equal to 4.9 seconds. So beza dengan atas apa? Okay. Kenapa belah kanan darab dengan 3? Basically sini pun darab dengan 3 juga. Ini sebenar pun 0.75 darab dengan 3. .25 tu adalah 0.75 darab dengan 3. Final value. Okay, ada question lagi? Ya, Yusuf Hikmal ni angkat tangan. Tak ada soalan. Yes, Yusuf Hikmal, you angkat tangan. Yusuf Iqmal angkat tangan, tanyalah soalan. Okay, ada soalan lagi?
Doctor,
Yes.
why have to multiply with U there?
Multiply with
U multiply with K.
U multiply with
K.
3.
K. The value of K, 0.75.
3 multiply with 0.75.
Yeah.
Ocean. Tahu tak pasti, takut. Final value is 2.25. Okay. And then apply with 2.25, 1.422, 1.25. Okay. And then berapa tadi? 0.98 multiply with 2.25, 2. This is 2.205, which is 98%. Okay, so the response of the system is like this, right? You apply the input 3, okay, to the system. It will settle to 2.25. That will be the final value lah, the steady state, right? So at steady state region, the value is 2.25. All right. And then we want to know what is the time for the system to reach 2.205. Okay, 2.205, which is 98% from the final value. Okay. Okay. So let's try with this one. 1.422 will equal to something, okay, multiply with 1 minus exponent negative negative 1 lah, time, because here t is equal to time constant, so meaning t over t. Okay, 1.422 equal to x 1 minus exponent negative 1. Okay. Alright, exponent negative 1. Berapa value? Ini exponentnya. Tak nampak.
0.3679.
0.3679. 0.3679. Okay. So you should get 1.422 divided by 1 minus 0.3679. Betul? Okay. So the x value here you will get 2.25. Okay. So 2.25 is actually the final value there. Okay, so X here is actually K multiplied with U. Okay, K multiplied with U. Okay, so that's why if we put the standard equation YT, because YT, the one that we derive is considering K equal to 1. So YT is 1 minus exponent negative T per T. Okay. Okay, so one here, this one here is the final value actually. Okay, because it is due to unit step input. Okay, that's why the value when you reverse, it become 1. Okay, so if so meaning 1 here, the value 1 here is actually representing the final value. Okay. Right, so kalau you reverse back, okay, you reverse back, so this value should represent the final value lah, K value, K multiply with U. YT is K 1 minus exponent negative T per T. Okay, this is the standard value. Standard equation. Standard equation together dengan K lah. Before this, we consider K equal to 1. But in these problems, we have value for K. Okay, K is not 1. K is 0.75. And then the input is not unit step input. Okay, so the input is actually 3. Okay, so we can rewrite the standard equation. So YT is equal to K multiply with input minus exponent negative T per T. Okay, so that's why we have K multiply with 3. K multiply with 3. Okay, ada lagi soalan? One there, 1 minus exponent negative T per T is for a unit step input. Okay, for a unit step input. Okay, okay. So let's start with derive YT. Y over U is equal to K over 1 plus TS. Okay, so now Y is K over 1 plus TS multiplied with U. So U U is not unit step input, but now U is 3. So U is 3 over S. Okay, so we have K over 1 plus TS multiplied with 3 over S. Okay. Partial fraction decomposition, you're going to have A over S plus B over 1 plus TS. Okay. So this part here is 3K over 1 plus TS multiply with S. Okay, so if you solve for A, A0 is 3K. Okay, if you solve for B, apa kalau you solve for B? B1 plus TS equal to 3K over 1 plus TS multiply S, considering S equal to negative 1 over T. Okay, this one is cancelled. So we have B equal to 3K divided by negative 1 over T, which is equal to T per 1 kan, negative 3KT. Okay, betul tak? Betul tak saya replace tu 1 over T, T per 1, negatif lah, betul lah tu kan?
Betul,
Okay.
betul.
Ha?
Betul.
So therefore YS kita is equal to 3K over S plus minus 3KT over 1 plus TS. Okay, so kalau kita inverse, YT is equal to 3K minus 3K exponent negatif negatif T per T lah tu, 1 per T kan, sebab kita kena inverse S plus 1 ni divide by T, divide by T, 1 over T divide by T. Okay, so negative T per T. Okay, so 3K 1 minus exponent negative T per T. Okay, so this is the time response for the system when you when the input is 3. Okay, so based on this equation we can consider, okay, YT is equal to Y final multiply with 1 minus exponent negative T per T. Okay, so that's why ini tadi yang your friend buat 3 darab dengan K, which is this one lah, 3K ni. Basically is considered Y final. Boleh?
Doktor.
Alright. Yes, Muhammad Ali.
So kita boleh wifi ni tu ganti dengan KU lah kan, Doktor?
KU lah. Sebab 3 ni adalah sebenarnya U lah. Tapi sebab tadi kita dah replace kan. U ni adalah 3 per S.
Okey, Doktor.
Ataupun you boleh buat general equation YT equal to KU. Okay. 1 minus exponent negative T per T. Okay. Alright, ada question lagi? Dah 5:30 ni. Okay, so I think we're going to stop here. Okay, good luck for your test tonight.